AP Cram, Calculus AB, Free Response, Exam Review. Question 55, Mean Value Theorem. Alright, so hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, where t is in the closed interval and is either greater than or equivalent to 0 minutes or less than or equivalent to 6 minutes, is given by a differentiable function c, where t is measured in minutes, like I just said. Selected values of c of t measured in ounces are given in this table above, okay? Is there a time t such that t falls between the closed interval of 2 minutes and 4 minutes, at which c prime of t is equivalent to 2? Justify your answer. And since I already gave the answer away in the title card, for some people this might be obvious. For others, it's not so much obvious, and that's okay. You need to know the definition of the mean value theorem. It might not be apparent, but for this particular time interval and this particular first derivative, they're just basically asking you for the definition of the mean value theorem. These are snippets of the mean value theorem. So I'll give you a moment to think about your answer, all right? Okay, so I already told you that you need to know the mean value theorem for this problem. But what's interesting is that they're saying at which c prime of t is equal to 2. But notice for the interval for 2 minutes and 4 minutes. Okay, so let's pretend that these are our y values, the rise and the slope. The difference between 12.8 and 8.8, that's c of 2 and c of 4, is going to be 4. And the difference between 4 minutes and 2 minutes is 2. So 4, the rise, divided by 2, the run, is going to be 2, just like our c prime of t. That's how we definitely know that we need to use the mean value theorem. And there's some other things that we're told in the question stem. We're told that the function c is differentiable. That's one of the stipulations in order for the mean value theorem to hold true. And the next thing that has to hold true is that for the closed interval that we're concerned with, the function has to be continuous. So here things seem pretty continuous. Okay, all right. So since c of t is differentiable for all the values in the closed interval 2 minutes, 4 minutes, we can say that there must be some value of t in the closed interval between 2 minutes and 4 minutes such as t equals a can be any value within this range, or within this domain, I should say, such that c prime of a, that is the first derivative of a, or the slope the first derivative, is equal to c of 4 minus c of 2 divided by 4 minutes minus 2 minutes, which I just kind of spoke out to you previously. So we have 12.8 ounces minus 8.8 ounces over the simplified version of 4 minus 2 minutes is just going to be 2 minutes. Therefore, that gives us a value of 2. And by the mean value theorem, the answer is yes. Okay, this might feel like for some people, but don't worry, just trust me on this. This is basically restating the definition of the mean value theorem using this specific example. All right, okay.